This episode of CppCast is sponsored by Undo Software. Debugging C++ is hard, which is why Undo Software's technology is proven to reduce debugging time by up to 2/3. Memory corruptions, resource leaks, race conditions, and logic errors can now be fixed quickly and easily. So visit undo-software.com to find out how its next-generation debugging technology can help you find and fix your bugs in minutes, not weeks. Episode 40 of CppCast with guest Dr. Greg Law, recorded January 8th, 2016. In this episode, we talk about tech startups using C++. Then we'll talk to Dr. Greg Law from Undo Software. Greg will tell us about how UndoDB and Live Recorder will change the way you debug. Welcome to episode 40 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
Doing great, Rob. How about you?
Doing good. I saw on Twitter earlier this week you shared your pictures. Do you want to mention that real quick?
Yeah, so one of the reasons why the podcast has been semi-irregular over the holidays is I got back from a Kenyan safari recently and a bunch of travel over the holidays and had a great time.
Yeah, the pictures are pretty nice. Do you have like a high zoom on your camera, or are you really that close to those animals?
We were easily within 25 feet of lions several times. Some lions walked right past the trucks. Wow. But I also did have a 30 times zoom on my compact camera. So some of them, it's even hard for me to remember on some of the pictures whether they were close up or whether they were zoomed in a lot. But it's a combination of both.
Okay, very cool. Well, maybe we can even put that Flickr link in the show notes if people want to check it out.
Sure.
Okay, so at the top of every episode, I'd like to read a piece of feedback. This week, I got a tweet from Guido, who's saying the CppCast episode with Richard Thompson is by far the best he's listened to so far. A must-hear for every developer, not just C++ developers. That was a while ago, but Richard Thompson was definitely a great guest. That was when we were talking about exorcism.io, which is the online kind of testing. How do you describe it, Jason?
It's like programming training, I guess, might be a
right. And it's kind of collaborative. Like you go through it and then you have someone reviewing your code. It definitely sounded like a really nice tool. I haven't yet actually gone back and tried it out.
Neither have I. Hopefully, the shows keep meeting his expectations, since that was a while ago.
Yeah, absolutely. Well, we'd love to hear your thoughts about the show as well. You can always reach us on Facebook or Twitter. Email us at feedback@cppcast.com. And don't forget to leave us reviews on iTunes. So joining us today is Dr. Greg Law. He is a co-founder and CEO at Undo Software. He spent nearly 20 years writing systems-level code, including novel kernel designs and networking architecture in academia and at a variety of startups. Greg finds it particularly rewarding to turn innovative software technology into real business development. He still gets to write some code, although sadly most of his coding these days is done on airplanes. Greg lives in Cambridge, England with his wife and 2 children. Greg, welcome to the show.
Hi, thanks.
So, novel kernel designs, is there anything about that you can share?
Yeah, so I spent a few years of my life kind of looking at how OS kernels were structured and the kind of mechanisms that were used to protect different sort of processes or entities from each other, and kind of investigating whether you can decompose the kernel down to very fine granularity and have different components for, like, scheduler, memory manager, that kind of thing, and then have those components actually be protected from each other so that, if one goes wrong, it can't stomp over the other, but yet do that in a way that didn't have very bad performance overheads. So I kind of we had got a cool way to play around with the x86 segmentation registers, and to allow sort of domain crossing in a very efficient way. So, and that's kind of started life as my PhD thesis, and so I made this OS called Go, and which was short for Gregos, and then subsequently Google stole the name, of course, for the language, but that came later. But some of those ideas kind of live on inside Zen, inside the Zen hypervisor. Although, unfortunately, when the 64-bit x86 CPUs came along, they kind of nobbled the segmentation stuff. So, but yeah, it was fun days.
Cool.
Very cool. So we had a couple of news items to talk about before we get into talking more about Undo software. The first one is C++ status at the end of 2015. And Greg, feel free to jump in with any of these. And this is kind of like just an overview of all the C++ news that went on in 2015. I feel like we've probably touched on this at one point or another over the past 10 months. But it's definitely a nice refresher. Was there anything specific you wanted to call out in here, Jason?
I don't recall seeing anything that really jumped out at me, but it is a lot of great information to look forward to what's coming and what has been in recent C++ news.
Yeah, I mean, just a couple highlights. Clang and GCC are now fully C++ 14 compliant. Visual Studio is making a ton of progress this year with C++ 11 and 14 as well. And, all the work that's been done towards C++ 17 with the different technical specifications. And then there was all the C++ core guidelines work out of CppCon, which is really exciting. So
I thought the increase in C++ popularity on some of the indexes was quite interesting to see as well. And it kind of, with some of these indexes, you kind of need to take it with a bit of a pinch of salt, right? Because it's just very hard to really have an accurate view on this stuff. But it corroborates the kind of anecdotal evidence that I've seen over the place as well, where, just a few years ago, people would tell me that, C++ is a sort of dying legacy thing. And, you certainly don't hear that anymore. And increasingly, I was just in one of the very large banks, just the other day, and they were saying that, they're kind of mandated that all the code will be written in Java from now on. This was a few years back, and they've kind of revoked that requirement now, and they're sort of seeing more and more C++. So, yeah, it's good to see it coming back.
Yeah, absolutely. That was from the TIOB index, where C++ is currently listed as number 3, just below C and Java, holding the number 1 spot. So it looks like C++ is kind of inching up more and more against C, which makes sense to me.
It makes sense to me too.
And if you combine the C and C++ together, then I think it gets the number 1 spot quite comfortably, right?
Yeah, so Java's at 21.4, C is at 16, and C++ is at almost 7. So yeah, together they easily trump Java. Cool. Kind of moving off of that, there was an interesting article on Medium about starting a tech startup with C++. And it was just an interesting read where this guy, I think he's the CTO for some new company, and they're working on a web service, and he decided it makes sense to write it in C++. And he had a lot of colleagues in the industry tell him, oh, that doesn't make any sense. You should be writing it in Ruby or Python, blah, blah, blah. And he just kind of went over his reasons why he thinks C++ makes sense. And it absolutely does. I mean, look at Facebook with, the amount of server time that they save by using C++ instead of one of those dynamic languages.
Yeah. And if one of the notes at the bottom here is this guy points out that his C++ example code is 40 times faster than the Python equivalent.
Yeah.
That's huge.
It's huge. And it's a huge cost savings for his new company.
Right.
Yeah.
I guess the thing with, and this is kind of to put my CEO hat on rather than the dev hat. When you're starting a company, the economies of the efficiencies kind of come out differently. So, server times, if you're starting up, it's not very expensive because you don't have that many, users to begin with, right? And I think particularly with kind of web services type stuff, I mean, it was impressive to see that 40x improvement. I read that article. And so it totally explains why the likes of Google, do that because they have millions of servers, and if you can improve, it doesn't need to be anything like 40x. If you can improve by 10% the amount of transactions per server you can handle, and you scale that across millions of servers across data centers across the world, then it makes sense to pay people the money to provide that efficient code, right? If you're able to just run on one or two EC2 instances, because it usually, and based on the premise that you can write the same code more quickly in something like Python or Ruby, then it kind of makes sense to just, because compute time is cheap and programmer time is very expensive, right? But I guess he's planning for success, and hopefully he'll have lots of users, and he'll get a return on that investment nice and quickly.
And you kind of led into something that we haven't talked about yet on this show, I believe. Some of these Facebook libraries that he mentions.
Folly, yeah.
Yeah, Folly, and some of the higher level HTTP servers and stuff for C++ that can make these things easier and more succinct in C++ than they typically are thought to be.
Right. So this next article is a little sad. It comes from Scott Meyers' personal blog. And the headline is Good to Go, and it's just talking about how he has made the decision to effectively retire from the world of active involvement in C++. I'm really glad we were able to have Scott on the show when we did, and I'm at the same time really excited to see what he decides to do next with his time. Jason, was there anything you wanted to add here?
No, I'm also interested to see, if he still comments from time to time on the direction of C++ or whatever else he goes on to do. And I believe it's just interesting to note, I think he said this is his 25th anniversary of involvement in C++.
Yeah, wow. 25 years of, guiding all of us in how to be better C++ developers, basically. So hopefully Scott's going to still listen to the show. I know when he came on, he told us he was a listener. So we wish you the best, Scott, and look forward to seeing what you do next. And then this last one.
I was kind of sorry. I just wanted to jump in if that's okay. But it's kind of. I was also sad to see that. I remember reading his books, way back. Well, maybe not quite getting on for 25 years ago, 20 years ago, certainly. And a lot of stuff being explained very clearly, and it was very interesting. But I wonder whether it's just a general sort of comment on C++. And as you said in the intro, I don't get to spend nearly as much time on the tech as I would like to these days. And if you're not, C++ is so fast moving and so big that there is an issue. I think that if you're not able to dedicate all of your professional life to keeping up to date and really understanding it all, then it's kind of hard, right? So I don't know what the answer is here, and I understand why it's as big as it is, and all that stuff is certainly very powerful. But for people like me who spend a kind of way less than 50% of their time developing, it makes it hard.
Yeah.
Well, Scott kind of started to try to address that in one of his most recent articles, suggesting that it's time to start deprecating some of the more dangerous and least often used features of C++, and to try to actually simplify the language down to what it needs to be. See if that goes anywhere.
Yeah, no, although it still has the issue of the fast movement, the new version coming out every 3 years, and a lot to sort of keep on top of, and sort of strikes me that C++ is less a programming language, more a way of life.
Great. So this last thing I wanted to bring up was from C++ Now conference are putting out their 2016 call for submissions, and there's actually a really short deadline on this one. The submissions are due January 29th, which is only 3 weeks from now. And then proposal decisions will be sent out February 22nd. Jason, you planning on trying to go for this one again?
Yeah, I'm going to make a submission again. I didn't mention on the show here that my submission to ACCU was denied, so I will not be going to that conference. But yeah, I'm going to see if I can go to Aspen again. It's a great conference and a wonderful venue.
Now, Greg, I know
I will be ACCU. So yeah, I'll be doing I did it first at the CppCon, but a talk on the GDB and tips and tricks with that, because having sort of slightly complained that C++ has got rather big, GDB's got pretty big as well over the years, and
that was a great talk, by the way.
Oh, thanks.
I'm sorry, go ahead. I didn't mean to interrupt, but...
No, I was just said thanks it was just nice to have the compliment, so thank you.
Do you have any plans to go to C++ now or CppCon again, Greg?
CppCon again, I hope to, if I can. C++ now, I don't think I'm going to get there this year. It's just a little bit too niche. My co-founder, Julian, went last year, and I think that definitely comes into the, kind of, if it's your way of life, then it makes a lot of sense. But if it's just sort of something that's related to something you do, it's a little bit too intensive, I think.
That's probably fair.
Yeah, I think, Jason, you're going to have to go by yourself again to C++ now to represent this show. I don't think I'm going to be able to make it this year, but hopefully CppCon I'll get to.
Very good.
Okay, so Greg, let's start talking about Undo software and UndoDB. Could you give us an overview of UndoDB to get us started?
Yeah, so at least in its original incarnation, it looks just like GDB. Actually, let me step back on that a bit. It's the fundamental technology is a way to record the execution of a program so that you can go back and see what it really did, right? And so we wanted to, but we didn't want to replace developers' existing environments. So we kind of made it debugger agnostic. And so you get different debuggers that act as the front end. So GDB is the one that you would use, sort of by default, and most of our direct customers who come to us, that's what they use because that's what they know. And then you use GDB within whatever environment you would usually use it. So some people just use it raw at the command line, but some people will use it within Eclipse or from within Emacs or however like that. But we have other debugger front ends as well. So there's actually the ARM DS5, stands for Development Studio 5. That's the sort of development studio environment from ARM, and that has a feature that their marketing guys call Application Rewind, but that's us underneath, right? And that's DS5 interfacing down onto us. And likewise, you get the Total View debugger from RogueWave, which is kind of aimed at HPC kind of stuff. That has a feature that their marketing guys call Replay Engine, and again, that's us underneath. So and we'll have some others coming out this year. And it really what it's about is giving these debuggers the ability to step and run the program backwards as well as forwards, right? So we all know that increasingly, well, I don't know if it's increasingly, but I think always developers spend a lot of time finding and fixing bugs. There's a quote I'd like to use from a guy called Maurice Wilkes, who arguably is the first person to be a professional programmer on a general purpose computer, because he was the first. There's sort of various claims of what was the first computer, and different sort of universities claim it, but the one at Cambridge was the first one to be used to solve real problems, right? And actually do real work other than, so run programs other than just proving that this computer thing worked. Anyway, so he was very involved in that, and in his memoirs he has a quote along the lines of he remembers with great clarity the moment when the realization came over him that a good part of the rest of my life was going to be spent finding errors in my own program. And that quote kind of makes me laugh, because I remember the same, like when I was, 15 or so, and just playing around with programming, and it was like, this is it's kind of hard to get right. And I think whatever we do with languages and with smarter ways to write code, it just encourages us to be smarter still, right, and push the boundaries. And so you just are always going to spend a lot of your time trying to make it work. And so we knew, and everyone knows that it's difficult because you're trying to think, how did that happen? Right. Why this variable contains the value that it does? It should be impossible. How can that be? And if it's, if you're lucky, the bug itself is very close to where it goes wrong. So, I don't know, you immediately assign null to a pointer and dereference it, and you get a core dump there and then. But all too often, the problem itself is somewhere in the history, back in history. So, we knew, you could see very clearly that if you could just step backwards, or if you could do things like put a watch point or data breakpoint on that bad value and run back to the line of code where that was changed, then that would be a very powerful way to get to the bottom of some of these very difficult issues. So that was sort of UndoDB and the genesis of that. And my co-founder and I, my co-founder, a guy called Julian Smith, we started over 10 years ago now, and released the first version kind of 2006, and it was very clunky, very slow, real kind of version. Well, it wasn't one, we called it 1.0, but really it was 0.1. But we've sort of developed it over the years, and for quite a long time with that, actually, we just did it in our spare time, sort of trying to get enough income coming in so that we could put food on the table. But and so it takes a long time, right? When you're working evenings and weekends on something, it just took many, many years. But eventually, kind of 3 or 4 years ago now, we had enough that I could quit my day job and go full time. A year later, Jules did the same. A couple of years ago, we were still 5 people in a big shed in my back garden, and we sort of gone from there. We've taken a few investment rounds. We're still kind of small, right? We're like 18 people, but we're having a lot of fun.
Awesome. So can we go into a little bit more about what platforms are supported by UndoDB? This is Linux and Android primarily? Right,
exactly. So it's just very tightly tied in the implementation to the Linux kernel. It's very much at the kernel level, so we don't care what, we don't have any dependencies on glibc or anything in user space. So anything that's running, officially, you would call it GNU Linux, right? Certainly Richard Stallman's very keen that it's called GNU Linux, because all of the user space you see is GNU. But actually for us, it really is Linux. It really is the kernel that we care about. So it just translates very easily over to Android, which is the Linux kernel, but a different user space.
So do you support anything like Raspberry Pi or any other small Linux platforms, or do you care?
Yeah, okay. No, we do care. And so, it's very implementation tied to the kernel and also to the CPU architecture. So we do a JIT binary retranslation of the code as it runs in order to be able to do what we do, in order to be able to pull out all of those non-deterministic inputs. So we know all about the x86 instruction set, and we have a full decoder for that, and we do JIT transformation on that, and we do the same on ARM. But beyond that, we don't care. So, we care very much what the OS kernel user space ABI is. We care very much what the instruction set architecture is. But beyond that, whether it's running on a Raspberry Pi or, a node in a big Cray supercomputer somewhere, it's all the same to us.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Do you hate it when your customer finds a bug in your code? Tired of spending ages trying to reproduce intermittent failures? At Undo Software, they know that debugging C++ can be hard. That is why their next-generation debugging technology for Linux and Android is designed for C++ users, and is proven to reduce your debugging time by up to 2/3. Embed Live Recorder within your program so that you have a complete record of your program's execution in production. Activate it in your test suite to solve intermittently failing tests, and replay it later for offline analysis. Memory corruptions, resource leaks, race conditions, and hard-to-find bugs can now be solved quickly and easily. Visit undo-software.com for more information and start fixing bugs in minutes, not weeks.
So, several tools that I've learned about recently for debugging and performance monitoring rely on being able to access the CPU hardware counters, and therefore cannot run on VirtualBox. Does UndoDB have any limitations like that?
No. So we're entirely a software implementation, which has pros and cons, right? So the main con being it's just harder, it's more work. But the main advantage being it gives you more flexibility and you're less tied to these things. So it works just fine in VirtualBox or on an AWS instance or something like that, we care only that it's a Linux 2.6 kernel or later, which these days is just everything, and I think like an ARM v5 architecture or later, or on x86. I think it needs to be like the Pentium or newer. So it's pretty generic, and that gives just makes it. We knew from the beginning when we did this that if people are going to be able to really use this, it really needs just to work as far as possible anyway, out of the box. And because when customers come to us for the first time, they're usually in crisis mode, right? It's hard when things are going well and everyone's happy. It's kind of hard to get them to pay any attention to you. But when things really aren't going well, then they'll when they've tried everything else, then they'll talk to us. And at that point, if then but there's a load of caveats and you need to change your code, or you need to do whatever it is, install a kernel module, or make sure you're doing this, then it just they're already in a crisis and they don't really have the time to do that. So and it does allow us to do some neat stuff as well. So there is when you get into the details of it, there's some kind of nasty things. Like, for example, some of the instructions are non-deterministic. So most instructions, if you add two numbers together and you have the same register state and the same memory state, when you do that, then you'd better get the same answer each time you do that. But other instructions, read the timestamp counter as one, but there are some others, will give you a different result even when you do them in the same state. So being able to translate those in the way that we need to is it gives us some power, and critically, I think probably most importantly, it allows us to deal with applications that have shared memory, right? And that's memory shared between another process or memory shared with a device. I mentioned that we run on some of the Cray and other supercomputers, and one of the very common models there is they use RDMA, right, remote direct memory access. And what that means is one node on the network will be able to write directly into the address space of another node. And you can imagine for a tool like ours, that can be problematic. But because we do that binary retranslation, we can actually intercept those changes and handle that case correctly.
So, maybe this is getting off in the weeds a little bit, but in that particular case, do you need to be running on all of the nodes that are interacting, or just an individual node would work?
Yeah, no, just an individual node will work. I mean, happily, there is enough kind of communication with the OS beforehand to kind of set that up, because, obviously, if you just allowed any process to write arbitrarily into another process's address space, then across the network, then that would be kind of anarchy. Right. So there is a kind of handshake where they say, right, well, this is the memory region where I'm going to use to communicate with, and then there's a kind of authentication thing that allows that to happen. So we can see that happen, and then we can know, all right, this is a memory region that we need to treat specially.
Okay.
So to bring it back a bit, you talked a bit about how, UndoDB kind of just works. What is the process like to switch over from GDB to UndoDB for a first-time user?
Simply, rather than using GDB, use UndoDB.
It's right? That simple?
And
okay.
Actually, it's that simple. And actually, UndoDB itself is it's a Python wrapper that, like most Python programs, have sort of grown over the years from 100-odd lines to I don't know how many tens of thousands now. But and then that will invoke GDB in the right way, so that actually you're using UndoDB underneath. We make it completely transparent. Or if you're using, say, Eclipse, if you look in the right place, there's a dialog box in Eclipse that says what the path to GDB is, and it's expecting just a path to GDB. But if you replace that with the UndoDB command, then Eclipse will use UndoDB and be none the wiser. And of course, it is actually in that it is using GDB in that case, right? And it's just we're the kind of back end. So we fit between the debugger, be that GDB, DS5, Total View, Trace32 now, whatever. We fit between the debugger and the program that's being debugged.
Okay.
So in UndoDB, you can step forward while debugging or step backward. You can run backward with the program. Is that correct?
That's right. Yep.
So, and you've mentioned Eclipse several times. What IDEs do you have that have have the integration to support the both go forward and go backward kind of functionality?
Most of them do already. So because actually GDB has had this capability for some time. It's really, really slow. So the vast majority of the front ends know how to take advantage of that. But if they don't, then you can at least, as long as you can at least type at the command line, you can at least then hit you can just type reverse next or whatever rather than hitting the button. But you can usually on most of them you can find the buttons. We've got patches for a couple of the lesser used one as well because customers like them or we like them. So there's the KDBG, which is the sort of KDE graphical debugger, and we've got we patched that, for example, to have those reverse buttons as well.
Okay.
But you can use standard Eclipse, Emacs. What else? I don't think. I guess they're the main front ends that customers use actually, Eclipse and Emacs. But they've had the backwards buttons there for some time.
Okay. You mentioned how the project is very closely tied to the Linux kernel. Are there any plans to support anything outside of Linux? Have you looked at that at all?
Yeah, plan is a strong word. But I mean, I think it's kind of interesting because it just depends on the two things it depends on, of course, is it's all about the return on investment, right? So what's the customer demand for it and how hard would it be for us to do? And as a young company, trying to get ourselves established and get our place in the world, it's very frustrating, but you're forced to be quite short-termist. Right. And I don't know, you can argue about whether that's a good thing or not, because actually if you have these long-term goals, you often find that you've based them on at least some of your assumptions were false, and then it's too big an investment to get there to learn. But anyway, for the rights or wrongs of it, the truth is, we have to be doing things that will return meaningful revenue to us in, the next 1, 2, 3 quarters. So it makes it very difficult to embark on some of these larger things like porting across to another platform. So, right. For example, when we ported across to ARM, originally we were x86 only. When we ported across to the ARM architecture, we did that very closely with ARM, the company, right? And they actually funded that effort. And we did that because we knew we were going to do the integration into DS5, so it was all kind of part of that. It would have been it would have been basically impossible for us just to decide we're going to go off and do an ARM version now and then see if that sells.
Okay. Should we talk a bit about your other product called Live Recorder? Does that kind of take UndoDB and goes a little further with it?
Right. It does. It takes kind of the core recording technology, but rather than being an interactive tool, it is a library that you can link against, and then that gives, and it's just a very straightforward C API to do things like enable recording, stop the recording, save the recording to a file, and some sort of configuration stuff as well. So that then, if you link against this library, it's dormant by default, but if you call in to turn on the recording or whatever, then it means the program can record itself effectively, and so you can then just deploy that program wherever, and particularly useful for independent software vendors who are shipping their code where they don't have any kind of control or visibility into it. So it might be a classic software vendor sending their code to somebody else, or it might be somebody who's kind of deploying code up into the cloud. But often when your code's running up in the cloud, it's quite difficult to get that visibility. And so when weirdness is afoot, the program can, under whatever circumstances it decides, it start the recording and then save that recording to a file, and then you can take that recording file and load it up somewhere else, another time, another place, and you load it up into UndoDB. So now you get all of that really cool stuff of reversible debugging and that ability to, go back and forth, wind the tape back and forth to see what really happened. In addition, you kind of solve that reproducibility problem, right? So you're sort of debugging offline an exact, precise copy of the failure as it occurred in production, and so that's the what we call the live recorder product. So the idea is you're recording those failures, as they really happen.
So what kind of performance overhead does Live Recorder have when you turn it on?
So it does have a significant, certainly very measurable performance head. So things generally run. I mean, it does depend an awful lot on the program. Sometimes it's not really noticeable. Sometimes it'll run about kind of half speed, and sometimes it can be a little bit worse than that. So most of our customers don't turn on Live Recorder all of the time. So actually, in sort of early days, it was the sort of internal engineering name for some time was Flight Recorder. We decided not to call it Flight Recorder for a couple of reasons. One, well, actually, there's some Java stuff called Flight Recorder, and we didn't want to get confused with that. But also, it's kind of a misleading because Flight Recorders are always on and only record sort of certain interesting things, right? The flight recorder is not going to tell you what the passenger in flight 43C had for lunch, which when a plane crashes probably doesn't matter, but when it's software, it might just be the problem, right? And so, so this just really records everything, or at least enough records sufficiently for you to be able to reconstruct everything. So we only record the non-deterministic inputs, but, where was I going? Yeah, but because of that performance overhead, usually you don't have it always on. We do have actually customers who put it always on because if they've got a low CPU overhead application that is exhibiting. We've got one where the customer sees it crash just literally a handful of times a year, and it's really, really hard to diagnose. It's not very high percentage CPU information, so they've quite recently deployed with that enabled all the time. Let's wait for it to crash, and then we can find out what's happened. But most of the time, you turn it on when it's going wrong. So either maybe it's a node in the cloud, and there's sporadically these problems, so we'll just turn on 1 in 100 instances or something, or you've got a customer who's complaining because this isn't working in their environment. Of course, we've all been there. Customer says, well, I do this and it breaks, and you try and do this, and you say, well, it works for me. So now you can say, well, okay, turn on the recording, and how that happens is left as an exercise to our customer. So maybe they, have a menu config option inside, or maybe they just can tunnel in and do it remotely, whatever, and to get that recording on and say, okay, now do that again, and now send us a recording file back.
I'm thinking about the way you've described how this is implemented, that you are recording all of the non-deterministic inputs and doing some form of JITting of the application code. And I'm thinking there's other things that you could be doing with this data other than debugging your program, like memory profiling or CPU profiling. Are there other applications, or are any of your customers abusing the product in ways you didn't intend for them to? Or
yeah, that's absolutely. So it actually opens up some really interesting possibilities, and ones that we didn't see in the early days. In fact, I remember back right at the very beginning when I was kind of thinking, should we do this? And I spoke to a few people, found some of the smartest people that I knew, and ran this by them as an idea. Do you think this idea is crazy, or do you think it might just work? And there's one guy I worked with years ago, really, really smart guy, and I ran it by him. And he said, yeah, that sounds like it'll be great. He said, I think there'll be lots of other applications beyond just debugging as well, if you can wind time back. And I said, oh, wow, gee, Pete, that's really interesting. Can you sort of elaborate on what that would be? And he said, well, I don't know. I can't quite give you any examples, but I'm pretty sure it's there. Yeah, thanks, Pete. That really helps. But actually over the years, and particularly with interaction with customers, I've realized, oh, I see what he means. And so Yeah, we've had. I mean, I can't sort of get into too many details, unfortunately, but we've had in the last sort of 6 months. I think four of our biggest, all four of the top four biggest customers have come to me and said, Greg, we love your stuff. One of them said it's like heroin, which is, I think he means it that he just needs it all the time now rather than it ruined his life. But this is really, really great for debugging. But do you know what? Could we use it to do X, where X is solve a particular kind of business application problem that they're facing that there's no way that I could envisage because I don't understand their business, right? So that might be, that's as diverse as from kind of EDA companies, running sort of simulators and synthesis tools to banks, trading applications to across the board. And they have specific things where they, just this ability to know what really happened, right? Is just fundamentally really powerful. And then to be able to start to, do kind of analyses on those recordings and put that together. And, I think there's a whole heap of really, really, interesting directions this can go in. Of course, we come back to what I mentioned just before that, we're trying to, grow the business here. And ultimately that comes down to decisions about what can we do that will generate revenue in the short term and also has the highest probability of generating revenue as well. So it kind of limits, I'd love if we would have a research department with, 100 people in it that would just go off and do all this crazy stuff and we'd probably find some really, really amazing things in there. But realistically, I think it's going to be a few years before we can actually do that.
So you talked for a second there about how your one customer was comparing it to heroin. It definitely seems like the type of thing, reversible debugging, where once you've had it fix some hard to debug problem for you once, you would get really hooked on it. Do you think reversible debugging is kind of becoming more of a thing in the industry? Like more and more developers are using it. It's becoming more popular because I definitely see that, maybe 10 years from now, it's just going to be like the standard that everyone uses reversible debugging all the time.
Yeah, I think so. I mean, that's why we started the business, right?
Sure.
Because we could see that this was, if you like, an idea whose time has come. It's just a much smarter way to do things. However, it is, I must say, frustrating how slowly things change and people's habits change and how, I remember when we launched version 1, which as I said is more like sort of 0.1, but it was a thing and it worked. And, I had a friend who a few years ago had his, it was back when I did OS research, and he'd had his new OS posted on Slashdot, and the web server had crashed under all the traffic, right? So, we warned our web hosting provider, said, well, we're going to launch this product and we're going to put a press release out and, probably not, but just be aware, just in case there's a kind of, there might be a bit of a spike in traffic. And they were like, yeah, okay, whatever. I've probably heard that before. And we launched and just like nothing happened, right? I mean, it was real, you just couldn't get anybody to see it or to care. And slowly over the years, it kind of people one by one kind of started using it, and those that use it, and whether that's using our stuff or other implementations of this, they as I say, it's like it's completely addictive, and they couldn't imagine working any other way. But yeah, it just takes so long for people to change habits, and I think still the predominant way people debug is with printf, and I think there's something about I think that when you're debugging, your mind is already completely full. You're already that quote from, is it Brian Kernighan, I think, the quote that debugging is twice as hard as writing the code in the first place. So if you make the code as smart as you can, how will you ever debug it? It's kind of related to that in that, so when you're debugging, you're just like your brain CPU load is at 100%. And so new things, trying to find new ways, even if they will make you much more efficient, it's just hard for people to do. So it's frustrating how, it is. I mean, it should be just like standard thing where it's available. I know it's not available everywhere, but where it's available, it's like it's a constant source of frustration to me that it's not just why isn't absolutely everybody using this stuff. But it will take time and habits will change, and you'll always have those dyed in the wool printf debug people. But so I think I'm not well known for my patience, but so I think probably when you say 10 years from now, sadly you're probably right. Sadly, it probably will take 10 years.
Jason, do you have any other questions you want to ask?
No, I don't believe I do.
Okay, well, Greg, where should people go if they want to find more information to get started with UndoDB or just find more about you?
Yeah, so undo-software.com, and that's definitely the first place to go. And everything is there on the products, and that's probably the best. There's not a lot of information on me. I don't think there is much of a way to find out about me. I think this podcast has probably been as much exposure as I've had in some in the last few years. So, but yeah, you don't care about me. You care about UndoDB.
Okay. Well, thank you so much for your time today, Greg.
Thanks a lot. Thanks
for joining us.
Thanks so much for listening as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, I'd love to hear that also. You can email all your thoughts to feedback@CppCast.com. I'd also appreciate it if you can follow CppCast on Twitter and like CppCast on Facebook. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. at CppCast.com. Theme music for this episode is provided by podcastthemes.com.